Hi, my name is Rob Power. I'm an instructional developer with the Advanced Learning Technology Center at College of the North Atlantic, Qatar. I'm also a doctoral candidate in the Doctor of Education in Distance Education program at Athabasca University in Canada, and I'm a member at large on the executive of the International Association for Mobile Learning. In 2013, I served as the project manager and conference chair for the 12th World Conference on Mobile and Contextual Learning, mLearn 2013, held at College of the North Atlantic, Qatar in Doha from October the 21st to the 24th. I've been asked to prepare a brief presentation on mobile instructional design and where I see mobile learning heading over the next few years. I'd like to start off with a quick look at how I define mobile and mobile learning. The first step is to focus in on what exactly constitutes a mobile device for mobile learning purposes. There's been a lot of debate in recent years as to whether we're talking strictly about mobile phones or whether we should be including tablet devices like iPads or even smaller traditional computers such as laptops or netbooks. I think that Kathy Norris and Elliot Soloway gave one of the best summaries of what a mobile device for mobile learning is when they spoke at mLearn 2013, and I'll let them tell you about it themselves.
And the reason they're doing it that way is because they have it with them all the time. They find that they can pull it out wherever they are because the children are carrying their devices all the time.
So in fact, the second transformation is technology. It's one-to-one, 24/7, ready at hand. We have a litmus test for what is a mobile device, okay? And Kathy actually said it a moment ago. If the child is walking home from school and sees the roots of a banyan tree, can they take the device from their pocket, take a picture, put it back in their pocket, and continue? That's a mobile device. Certainly you can do it with the smartphone. You can't do that with a laptop. Laptop's in your backpack. It's tucked away nice and safe. 10-inch tablet? No. It's tucked in the backpack. 7-inch tablet? Now it's an interesting question. Is that a mobile device? Is it not a mobile device? For sake of argument, yes, it's a mobile device. Because they're walking, they take it out of their pocket, boom, take the picture. That's a mobile device. It is truly ready at hand. It's on. It's instant on.
Kathy and Elliot's thoughts on what constitutes a mobile device are reflected in the definition of mobile learning provided by Wexler et al. 2008. They define mobile learning as any activity that allows individuals to be more productive when consuming, interacting with, or creating information mediated through a compact, portable digital device that the individual carries on a regular basis, has reliable connectivity, and fits in a pocket or purse. So what exactly are mobile RLOs? One of the most concise definitions of mobile RLOs comes out of the University of Wolverhampton, where one of my colleagues, Professor John Traxler, has been working as the world's first professor of mobile learning. They say that a mobile RLO, or a reusable learning object, is any digital object that can be reused to facilitate and support learning activities. Access to RLOs is typically free. The reusable nature of RLOs enables them to reduce the effort required to deliver content and instruction. The digital nature of RLOs enables them to be embedded into learning activities and virtual learning environments such as learning management systems. In the case of mobile RLOs, the digital objects are designed to be accessed and used via a mobile device. Now that we're narrowing in on a common definition of mobile learning and we know what mobile RLOs are, we need to start thinking about where mobile learning research and practice are heading over the next few years. I think that the featured panel discussion at mLearn 2013 gave us a glimpse of where things are going. When asked what the current single greatest barrier is to wider adoption of mobile learning practices, mLearn founding member and Athabasca University researcher Dr. Muhammad Ali said that it was the human element, teacher confidence. Teachers still lack confidence in the technology, and they lack confidence in their ability to integrate the technology into their practice. As we shift from talking about mobile learning and into talking more about ubiquitous learning, it's becoming apparent that the technical deployment issues we've worried about over the past few years are disappearing. Mobile technologies are becoming more robust, more ubiquitous, and easier to use. And that leaves us with the problem of teachers' perceptions of self-efficacy. That's why my own research is now focusing on providing frameworks to support teachers' pedagogical decision-making. I'm looking at leveraging free, open resources to do the heavy lifting of building mobile, reusable learning objects, and using a framework that I've developed called CSAM, the Collaborative Situated Active Mobile Learning Design Framework, to help teachers draw upon their existing pedagogical expertise to design sound mobile learning experiences for their students. That's where I think mobile learning is heading in the years to come. We've got the technology to do whatever we can imagine, so it's time to put the focus back on the design of the learning experience itself. The following quote from Kenny et al. 2010 highlights the critical role that teacher efficacy plays with respect to the successful integration of educational technologies. Unfortunately, it also highlights the fact that not enough attention has been paid to teacher efficacy in a mobile learning context. So what exactly is the Collaborative Situated Active Mobile Learning Design Framework? The CSAM framework started out as the mental model that I used when designing the mobile RLOs I used for the QR cache research project at College of the North Atlantic Qatar. In that project, I used free online resources to build RLOs that students accessed by scanning QR codes mounted on parts inside of working computers. The RLOs were designed to provide information such as the English terminology for the components and their basic functions. I made sure to include interactive elements such as test your knowledge surveys. I let my students freely explore the computers in the laboratory for a class period. Then we accessed the summaries of the test your knowledge surveys, which sparked whole group discussions about the topics for the lesson. After reviewing numerous case studies of mobile RLOs and attending conferences like mLearn 2012 in Helsinki, Finland, I began to realize that the mental model I used to guide the design of the QR cache RLOs shared a lot in common with the instructional designs that were being reported from around the world. So I thought it would be helpful to summarize those common pedagogical factors. What I came up with was the CSAM framework. Essentially what CSAM tells us is that RLOs designed for collaborative learning must include explicit consideration of 4 key pedagogical elements. They must be collaborative. That is, they must be designed to get learners working together towards a common objective. They must be situated in a realistic context. Learners are more highly motivated, and learning is more effective when the context is realistic and personally meaningful. It helps learners to draw connections between the current learning, prior knowledge and experiences, and how new information and skills are transferable to their own contexts. The mobile RLOs must prompt learners to engage in active learning. That is, they must not simply be passive recipients of information. Learners must have a personal goal that is motivating their activity, and they must do something with the objects they are studying. That something can be the production of new information, the development of new skills, or the creation of physical or virtual artifacts to represent what they have achieved. Finally, the learning activities must be mobile. And by mobile, I don't just mean the technology. I'm referring to pedagogical mobility. The RLOs must facilitate the ability of learners to be mobile within their learning context, both in terms of time and space. Learners must be freed from traditional classroom instruction models and provided with personal mobility to explore and accomplish learning tasks when it's convenient and appropriate. As part of my dissertation work in the Doctor of Education in Distance Education program with the Center for Distance Education at Athabasca University, I decided to take a closer look at the CSAM framework and how the framework could help educators to become more comfortable and confident with integrating mobile RLOs into their practice. One of the first things that I did was to quantify the prevalence of CSAM strategies in recent mobile learning literature. I looked at 403 articles and chapters for mobile learning publications over the 5-year period from 2009 to 2014. Those included some of the prominent textbooks that have been released, such as the Handbook of Mobile Learning, as well as the first 5 volumes of the International Journal of Mobile and Blended Learning and the proceedings of the mLearn conference series. What I found was that over 1/4 of all of the articles and chapters either focused on mobile RLOs or included a distinct RLO or a combination of mobile tools as supporting examples. Of those, 86% were explicitly collaborative in nature, and 82% of them included all 4 of the CSAM pedagogical elements. 96% of the examples included 3 of the 4 CSAM elements. The most common element that was omitted was the situated context. I also turned my attention to relating the CSAM framework to other learning theories and frameworks. One of the first frameworks that I looked at was Kuhl's frame model, the framework for the rational analysis of mobile education. Frame provides an excellent holistic view of mobile learning that integrates the learner aspect, the social aspect, and the device aspect, but it doesn't provide specific pedagogical guidance. CSAM has also been heavily influenced by activity theory and the zone of proximal development. I've already discussed the active element in CSAM and how learners must have goals and interact with objects to produce something new, either new knowledge, new skills, or new artifacts to represent their achievements. What the zone of proximal development tells us is that learners on their own can only achieve so much. But when working collaboratively, as in CSAM learning design, they can draw upon collective knowledge and skill sets to achieve far more and to become more effective independent learners in the future. CSAM learning design also helps to reduce transactional distance between learners, their peers, their instructors, and the content with which they're interacting. CSAM learning design is also congruent with both the ARCS model and the TPAC framework. CSAM learning design specifically addresses each of the 4 components of the ARCS model for increasing learner motivation and engagement. CSAM also addresses the pedagogical components of the TPAC framework in a mobile learning context. So how am I using CSAM to promote teacher efficacy with mobile learning and student achievement? As part of my dissertation research, I've developed a short MOOC format course about mobile learning instructional design called Creating Mobile Reusable Learning Objects Using Collaborative Situated Active Mobile Learning Strategies. The course provides an overview of mobile learning and mobile RLOs and the CSAM framework. It then guides practicing teachers and graduate education students through the process of using CSAM to frame instructional design decisions for the development of mobile RLOs for their own teaching areas. Participants then use the designs they've developed to build actual RLOs entirely using free online resources. The idea is to let the free tools do the heavy lifting of building the RLOs, thereby reducing the cognitive load associated with having to master new educational technology tools so that the teachers can then focus on what they're already experts in, pedagogical decisions. I'm using a survey tool that I've developed, adapted from the Ohio State Teacher Sense of Efficacy scale, to determine if this approach has any effect on increasing teachers' interest in and confidence with using mobile learning strategies. In my own teaching practice, I've also used CSAM to help guide student work. I've frequently integrated projects where my students have worked in teams to build their own mobile RLOs to teach their peers about a topic. I've provided them with an overview of the CSAM considerations and guided them through the process of designing and building RLOs that integrate the 4 CSAM elements. What I hope to learn from my current research is just how useful the CSAM framework is for getting more teachers to integrate mobile RLOs into their teaching and learning practice. I also hope to take what I learned from my dissertation work to refine the MOOC I've developed and to turn it into an open educational resource, or an RLO itself, that schools and teacher training programs can integrate as a professional development resource. Thank you for your time. My contact information is included in this presentation. I'd be happy to hear from you and to answer any questions that you might have.